if I run Dijkstra's algorithm on a graph, it's going to give me the shortest path from the starting vertex to every other vertex inside the graph. So, so it's going to use general graph search algorithm, and I'm going to use a priority queue as a data structure, and it's going to sort based on path weights. So don't get this confused with prims that sorts on edge weights. Dijkstra's is searching for the shortest path to each vertex, so it's going to sort based on path weights. So there's three things that I want to do that general graph search requires me to do. The first thing is I'm going to update all of the weights. So let's do an example. So graph search algorithm starts out, add the starting vertex to the priority queue. When you step inside the while loop, you're going to pop it out. So from here, a few things I want to do is I want to add the path. So this is sort of trivial right now, but to get to A from A, I have to add, I want to add the path, that path cost to each of the new available edges. So starting at A to get to A has cost 0. So I'm going to say 2 plus 0 is 2, 3 plus 0 is 3, 1 plus 0 is 1. That'll make sense as we continue on. So once I've updated all of the edge weights, now I have to add each of its neighbors inside the priority queue. So A can go to B with cost 1. A can go to C with cost 2, and A can go to D with cost 3. So once I've added all of its neighbors, I'm done with A. And now I can pop the next element outside of the queue. So we're choosing this edge AB. AB with cost 1. So eventually what I'm going to return, and this is the third thing that I didn't mention before, but eventually what I'm going to return at the end of the method is a hash table. So I have key value pairs. So for the vertex B, I'm saying starting from A to get to B, I can get there with a total path weight of 1. So that's one of the things you have to do. The second one is I've added this path to my graph. So now I have to update all the available edges. Okay. So 1 plus 4 is going to be 5. Once I've updated all the edges, now I can add this edge, BG, to my priority queue with weight 5. So from B, I can get to G with weight 5. Okay. So now I'm done with edge AB. Forgot to mark that out. No. So the next edge is going to be AC with cost 2. So A to C. So I'm evaluating this edge here. So the first thing I have to do is put it inside my hash table. So for C, I can get from A to C with total path weight of 2. Now I have to update all of the available edges. So this is no longer 3. This is 2 plus 3 is going to be 5. And that's just saying I'm adding the path to get to C plus the cost it takes to traverse that. So now I have to add all the neighbors of C to my priority queue, and A has already been visited, so I only have to add C to D with cost 5. Right. And notice I'm maintaining a priority queue where everything stays sorted. So pop out the next edge. Now I have A to D. So I'm adding this edge here, or selecting that as the shortest path to get from A to D. So I add that in my hash table. I get to D with cost 3, and now I have to update all of the weights. So C's already been visited. I don't need to update this. Plus, it wouldn't be shorter to go from. It wouldn't cost less to go 3 plus the original 3 to get to C. So I wouldn't have to update that anyway. But to travel to D costs 3. To get to E from there costs 4. So that's total path 7. And we do the same thing. 3 plus 1 is going to be total pathway 4. So I have to add each of the new neighbors into my priority queue. So D to E with weight 7, or let's erase these used ones. Or I can go from D to F with weight 4. So D, F with weight 4. So notice priority queue is still sorted. So I pop out the next edge, D to F. So we're selecting this edge. I add it to the hash table. Wait, 4. And now I have to update all of the weights. Okay. So it costs total weight of 4 to get here. So now this edge, it's going to cost me 4 plus 2 is going to be 6 to traverse along this path to get to G. You'll see it actually is faster to get to G this way, but our priority queue will sort that out for us. So I have to add the new edge, so I can go from F to G. So F to G with weight 6. And now I'm done with that edge, D to F. So the next edge is B to G with weight 5. So B to G, G with weight 5, and updating the links, or updating the edges, we don't have to do anything because F's already been visited, so it doesn't make sense to say 5 plus the original 2, so 1 plus 4 plus 2, we don't want to update this to 7. There's no neighbors to add, nothing to update, so we're done with BG. So now our next edge is CD with weight 5. So C to D with weight 5. D has already been reached with path weight of cost 3. So there's no reason to go there with path weight of cost 5. Next edge is D to E. So from D to E, I'm adding this edge here. So first thing I have to do is put it inside the priority queue. So E, that was weight 7. So D to E with weight 7, and there's no neighbors to update, and there's nothing to add into the queue. And you can see that each of our vertices have been visited, and if you double check, these are actually the shortest edges. So all we have to do at this point, when everything's inside the visited list, is return back that hash map when we're done.